All right, so today we're going to take a look at derivatives of exponential functions. So two types of exponential functions that you're going to see is a number being raised to the x power. Really right here, a is just a constant. So we can see like 2 to the x, 3 to the x, 4 to the x, or you could see e to the x. Now I want to kind of show you guys that these derivatives, right, the rule is if I'm taking the derivative of a to the x, it's still just a to the x, but we're going to multiply that by the natural log of the base, whatever that a is. Now, the derivative for e to the x is actually the same, where it's e to the x times the natural log of e. But the thing is, since the natural log of e is 1, you're not going to see that, but it might be helpful to think of it. But you would typically just see e to the x as that answer. So let's take a look at a couple practice problems, and we'll get some derivatives going. So if we want to find f prime, if f of x equals 2 to the x plus 3e to the x plus 2e, we would say f prime of x equals, and we'll just go term by term. So the derivative of 2 to the x would be 2 to the x times the natural log of 2, plus the derivative of e to the x is just e to the x, and that 3 is a coefficient, so we're going to leave it as 3e to the x. It's the same thing, right? Plus, this doesn't have an x next to it, so the derivative of 2e is just a number, so it's 0. So our derivative would be 2 to the x times the natural log of 2 plus 3e to the x. Now, sometimes you guys are going to be asked to find slope. So in this case here, we're given f of x, and we want to find f prime at 5. So the first thing we do is we find f prime of x, which is just the same thing, e to the x. Remember, we are still multiplying it by the natural log of e, but since the natural log of e is 1, right, it doesn't change. Then if we want to find f prime at 5, we can do this without a calculator. We're just going to leave it as e to the 5.